you guys can do the thing no matter what you're doing, no matter what you're trying. I believe you guys can get it done. So, how are you all doing today? Where's my CPU? Really? Why is my CPU usage so damn low? Like, I don't know. Whatever, I can totally make the CPU usage fast if I want to. Alright, that's cool. Also, why did my RAM go down? Alright, I deleted things. Cool. So I can make faster CPU preset. Cool, wonderful. So, cool things. One is I upgraded my internet. So now, instead of streaming at a 2K bitrate, I'm streaming at a 3K bitrate. And also I realized I have a pretty fast CPU. So, I can, make, my CPU use the faster preset for the video encoding. So I'm pretty excited. So how are you all doing today? How is everyone? Today is Sunday, as you probably know, because I stream on Sundays. Well, for the 68K, I stream on Sundays. For Haskell, I stream on Saturdays. A bit of note is I'm planning to add a subscription service. This subscription service would basically be like a much better, like, I'm going to teach you C#, and I'm going to basically teach you C#, how to program, how to code. I'm going to try to aim it toward people who are coming from JavaScript. Vanilla JavaScript, not like TypeScript. Although I might help too. Sorry. It's going to be recorded. It's going to be fancy. So I think the idea so far, what I have is Squarespace, my website, www.thatprogrammingguy.com, will have the latest episode that I've recorded. So I'll be recording this episode for the subscription service once a week. So I'm thinking maybe doing it after this one or after Saturday. So I'd record, I'd stream it, and then it's available on Twitch for as long as it's there. And then I would have it on my That Programming Guy website. So I'd stream it, record it. So I'd stream and record. Once it's done, I'll then spend the hour editing it, make sure it looks great, add the intros, add the outros, add all that wonderful good shit. Once that's done, upload it to my website, and have it there. And then the subscription service would allow you to watch all the backdated episodes. So you can see the most recent, and if you want to see the more past ones, you would have to sign up. I'm thinking $20 a month, which is actually cheaper than Pluralsight right now. And then Squarespace has a login, so it handles all the password stuff, because I am not going to roll my own password management system. Fuck that shit. Anyway, so where are we now? Well, the 68K programming, as you might remember from yesterday being last week, we kind of finished the get addressing mode. And then we started to change add, we started adding to add to do all this stuff. So the question still remains, though, of this, if you go back, if somebody, did this, D16AN, where in the binary do I put the 16-bit number? Where do I put that, right? So I need to read that. So I spoke to one of my coworkers on Thursday or Friday. I was like, yo, actually, no, where we were actually was we had to add the register information to DNA and all that stuff. That's the problem we're working on, but I'm going to change that problem right now. So I spoke to my coworker. I'm like, yo, where do I actually put like this D16 or this D8? Where does that go in the binary? And my coworker's like, since it's more of a common problem for different addressing modes, probably it's in a different location than on each specific mnemonic or each specific addressing mode. So we're going to go through this manual. Oh boy, and we're going to read it. Because really, it's like, where does that go? And this is still only for the integer unit programming model. I'm not going to attempt the floating point right now. I might have to attempt the floating point, but Fuck that shit. Okay, I've had too much water. I'm starting to slow down now. So, no water in the moment. So, where organize of data in registers? No. Instruction format, effective addressing modes. Effective addressing modes: summary, brief extension, word format, full extension addressing modes. That's interesting. Okay. Instruction summary, data movement, logical, yes. So where would the best place to go would be that? Maybe? The following paragraph is a summary of the binary encoding fields. The field specifies which addressing mode is used. No, register memory field, source specifier field. The field is common to all conditional instructions and specifies the conditional test. No. Shift and rotate. No. Count. No, that's not what I need. Op mode field, address data field, operation code map. What the hell? No, let's go back up the top. Let's see. Let's read about instructions, shall we? Most operations take a source operand and a destination operand, compute them, and store the results in a destination location. Single operand operations take a destination operand, compute it, and store the results in a destination location. External microprocessor references to memory are either program references that refer to program space or data references that refer to data space. They access either instruction, word, or operand for the instruction. Program space is the section of memory that contains the program instructions and any immediate data operands residing in the instruction stream. Data space is the section of memory that contains the program data. Data items in the instruction stream can be accessed in that instruction format. M6800 family instructions consist of at least one word. Some have as many as 11 words. What's a word? Instructions contain between 1 to 11 words. So what's a word? Really need to stop becoming overhydrated. It illustrates the first word of the instruction, called the simple effective address operation word, specifies the length of the instruction, the effective addressing mode, and the operations to be performed. The remaining word, called brief and full extension words, further specify the instruction operands. These words can be floating point command words, conditional, predicate to meaning operations, extensions to the effective address mode, specified in the simple effective address operation, word, branch, displacement, bit number, or bit field specifications. Special register specifications, trap operands, pack and pack constants, or argument counts. So we can have a single effective address operation word, when word specifies operation and modes. Special operand specifiers, if any, 1 or 2 words. Immediate operand, up to 6 words. Okay. And instruction specifies the function to be performed with the operation code and defines the location of every operand. Instructions specify an operand location by register specification. The instructions register field holds the register number by effective address. The instructions effective address field contains addressing modes information, or by implicit reference, the definition of the instruction implies the use of specific registers. Okay. I don't really am getting under that because my body's like, you have too much water right now. Also, guys, let coffee into your life. It'll be much better. So how is the quality so far? Is it good? I hope it's better, right? Say my name, say my name. Bo to bo to bo, bo, bo to bo. I'm not dropping in your frames, am I? I don't think so. No? How is my CPU looking? CPU's fine, so I can totally change my CPU preset for gaming. Awesome. The single effective address operation word format is the basic instruction word. See figure 2.2. Is this figure 2.2? The encoding of the mode field selects the addressing mode. The register field contains the general register number or a value that selects the addressing mode when the mode field contains opcode 111. What's so special about opcode 111? Some indexes or indirect addressing modes use a combination of a simple effective address operation word followed by a brief extension word. Yes, that's what we're getting at. Other indexed or indirect addressing modes consist of a simple effective address operation word and a full extension word. The longest instruction is a move instruction. With a full extension word for both source and destination effective addresses, and 8 other extension words, 8, 9, 10. It also contains 32-bit displacement and 32-bit outer displacement for both source and destination addresses. Figure 2.2 illustrates the 3 formats used in an instruction word. Table 2.1 lists the field definitions for these 3 formats. Okay, we have a source, CRC, and destination full extension word. 32-bit base displacement. 32-bit base displacement. Wait a minute. 32-bit. Never mind. Single effective address. So this is like add almost, where it's like we have this. The effective address is from 0 to 5. Brief extension word format. As DA, register, WL, scale, wide and long? I don't know. Scale, 0, displacement. Full extension word format. So I'm saying this, I'm guessing it's like this is 3 words. This, and this. I think. The mode is the addressing mode. The register is the general register number. DA is the index register type. WL, word or long word index size. Scale, 1, 2, 4, or 8. Base register suppresses. Index suppression, base displacement size. Index indirection selection. Effective addressing modes. Okay. Besides the operation code, which specifies the function to be performed, an instruction defines the location of every operand for the function. Instructions specify an operand location in one of 3 ways. A register field within an instruction can specify the register to be used. An instruction's effective address field can contain addressing mode information, or the instruction's definition can imply the use of a specific register. Other fields within the instruction specify whether the register selected is an address or data register and how the register is to be used. Makes sense. We went over this. Section 1 introduction contains detailed register descriptions. An instruction's addressing mode specifies the value of an operand, a register that contains the operand, and how to derive the effective address of the operand in memory. Each addressing mode has an assembler syntax. Some instructions imply the addressing mode for an operand. Some instructions imply the addressing mode for an operand. These instructions include the appropriate fields for operands. These instructions include the appropriate fields for operands that use only one addressing mode. Cool. In the data register direct mode, the effective address field specifies the data register. Yes, that's AN plus size. Okay. I remember reading all this. In the address register indirect with post increment mode, the operand is in memory. The effective address field specifies the address register containing the address of the operation in memory. After the operand size is used, it is incremented by 1, 2, or 4, depending on the size of the operand, byte, word, or long. Coprocessors may support incremental. No, this is not what I need. I think this is what I need. I don't know. Say my name, say my name. In the address register indirect with displacement mode, the operand is in memory. Yes, the sum of the address in the address register plus the sign extended 16-bit displacement integer in the extension word is the operand's address extension word. Yeah. So there's the contents of the address register that we have it. We add this, the displacement, the sign extended integer, right? So where does this go in memory? You know, if the contents are 0 to 31, this is 0 to 31. And why am I doing 0 to 31? Oh, come on, head. Oh, don't be a dick right now. In the address register indirect with the displacement of the operand is in memory the sum of the address. Yeah, so where does the 16-bit displacement integer in the extension word? Oh, so it's just extension word. Extension word. The index register includes size and scale information. The index register indicator includes size and scale information. Some of the operand's address, the sum of the addresses register contents, the sign extended displacement value in the extension word's low order 8 bits, and the index register's sign extended. Okay. So I think the extended word is something that we're looking for. Index register. The operand's address is the sum of... Okay, so I'm assuming then this... In this mode, the addresses or index and displacement are all optional. The index register indicates the size. An optional 632-bit signed extended base of the operand is in memory. The base and the scaled contents of the signed extended index. Okay, so I'm looking for extension word and the index register. Is what I'm looking for. But I'm slowly learning. Single effective address operation word format. Register mode of that. Brief extension word format. Full extension word. Oh, I see. This is an extension word, which looks like this. Okay. But where does it go? I'm assuming I just get like add, which is 0 to 15. At least one word, some as many as 11. Figure 2.1 illustrates the general composition of an instruction. Instruction word general format. The single effective address operation word, special operand specifiers, immediate operand or source effective address extensions, and destination effective address extensions. So does that mean they just come one after another? Is that the idea? Single effective address operation word. Special operand specifiers, immediate operand or source effective address extensions, destination effective address extensions. Huh. So it seems like it would be the add. So from what let's say take add, right? Can you guys still see what I'm writing, or am I too down? Or am I too far down? Yeah, I'm going too down. So like right here is the cutoff. So I can go about like halfway down the page before you guys can't see what I'm doing anymore. Can I do this? Can I just slowly move it this way? There, now you can see a bit more. It might not be the best. How's my CPU doing? You're doing fine. But now you can see more, and I can use more of this page. So if we take add, right? That's 15 bits. 16 bits. I'm assuming 16 bits is a word. Special operand specifiers, if any, which there's none. immediate operand or source effective address extensions or destination effects. So remember, add can either be EA plus DN goes into DN, source and destination, or DN plus EA goes into EA. And so in this case, the source would be right here. Otherwise, the destination would be right here. And saying they're all 0 to 15. So basically, it's add, which is 0 through 15. Special operand specifiers, none. So I think 0. Then we have the then either basically this would be either another 0 to 15 or this would be another 0 to 15. I think. So in this case, if we go down to add, we have add, right? It would be 1101. Add a byte. And that thing's like, there's not a lot of things on the internet that'll help me with this. Operand size is 8, 16 to 32. Word is 16 bits. Register, which is register op mode. Guys, remember when you're taking notes like this, just go slow so you can actually read what you're doing. So yeah, effective address, which is just basically the mode and register. And then if we go back to whatever the fuck page we were at, which I don't know off the top of my head anymore. Oh, we were at 2. We were at 2.1. So we can go all the way to 2.1, guys. Come on, chat. Help me out here. Do 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 do. Say my name, say my name. Bo 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 bo. All right, so that's 15. Special operand specifiers, if any, 1 or 2 words. Oh, I see. Because of 2 words, it would be 31. Okay, I get it. So now let's say we have the D16AN. Let's do. Come on, can I do this? Can I just duplicate this? Can I open you up in a new window? Bastard. Fine. Here we go. All right, so now we have that, right? Cool. So now this 15, right? So now let's say I do the D16AN, right? D16AN. Go back to 2. Oh, hey, this is what we're looking for. So the address register is... So let's say EA is the source, right? If any, 1 to 6 words. So this is 2, 3, 4. This is 4. In the address register, the operand is in memory. The sum, so I'm guessing this would just be blah, 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 and this would be 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And if this is the source, we'd have the address register, which is 2 words. So we would have, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then the displacement plus a sign extended 16 in the extension word is the operand's address. I think that would be this, immediate operand or source effective address. And so basically it would be this, if any 1 to 6 words. So it would be a 16-bit number. So like, let's say I'd want one, I don't know, 32? Let's just do 32. No, let's do 34, which would be off the top of my head. 34 would be 0 for the 1, 0 for the 2, 1 for the 4, 0 for the 8, 0 for the 16, 1 for the, so it'd be 0, 1, 0, 0, 0, no, 1, 2, 4, 8, 16, 32. I should be right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Yeah, 0, 1, 0, 0, 0, 1. Awesome. So then it would look like this. Oh, and assigned extended, so there's potentially two words here. 0, 1, 1, 2, 3, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then we have the destination E, but we don't have that. So I think basically this is how it's going to look. Basically, we have the first one is the 15 bits for the single effective address operation word. So if you go down to like add, let's look at the other one show. Oh, that's not what what the hell did I press? Oh, do 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 do. Say my name, say my. I don't know why that's stuck in my head right now. So it's just 15 bits, right? So we're gonna like add ADDA. Adds the source operation to the destination address register and stores the result in the address register. The size of the operand be specified as a word or long. The entire destination address register is used regardless of the operation size. I just hope I didn't like put something on here. Add address, 15 bits. Register field specifies any of the 8 data registers. This is always the destination. Mode field, word or long. Effective addresses, ADDI. So there's no effective address in here. Yeah, it's mode and register. Okay, so I think that's what it is. Basically, we do the 15 bits for the instruction. So basically, each instruction is 16 bits. So each instruction is 1 word long. And then we include the special operand specifiers, which I don't know what it is, but we'll probably find those as we keep going. Then we have 1 to 6 words of immediate operand or source effective address extensions, which is where the data goes into, and then we have the destination effective address extensions. So potentially one instruction could be a lot. So if we go to move, right? Let's see what move says. Move. We're getting there, guys. Hold on. Moves. Move C. Move EC. Move USP. Move to SR. Move to SR. Move from SR. Status register. F save. Move from status register. This is not in what I'm programming in, but it's nice to look at anyway. That's it. Instruction fields. Okay, then never mind then. Aha, move to user stack pointer. If in supervisor state, then USP user stack pointer goes to an address register, or the address register goes to the stack pointer. Interesting. Else trap. Word for the instruction format, the DR field is 0 or 1. Okay, I see. So that's what it looks like. All right. So I think we figured out the problem. That is what we need to do. Okay, so we figured that out. That took a long time. So basically, the source or the operand, we do have 0 to X many words. I think 1 to 6 words for the meaning operand destination. So basically, we have now solved the problem of where, when we're writing out the binary, do we put the extension words? Figured that out. So the next step that we're worrying about is we now need to put the addressing modes into the effective address. Because if somebody says, like, if we need, nope, you don't want to see that. If we go to the effective addressing modes, all the way up here, too far. Hey, word, long word, quad word. Damn. I need to go to effective addressing modes. Awesome. Oh no, I need to go to the add instruction. Let me go to the add instruction. That's where I need to go. Because I need to show you guys the problem we're working on now. Now that I figured out that problem. Add, right? Boom. Done. Wonderful. So basically, the register for mode 0, 1, 2, 3, 4, 5, 6 is the register that's given. And so I don't have that here because I'm just saying if you're just DN, the effective address is this. Now, there are ways I can do this. So, I think what I was, you done fucked up. Let's change that to a lowercase u, shall we? Now the question is now, how am I going to do this? How am I going to go, oh, hey, if it's this. Now I could do this, right? Effective address is mode or register, which is null, get mode, get register, set register. Now, I thought of something quite interesting, right? I could actually give it a conversion. Data register to binary. And I could say, to get the register, I would, let me show you guys. Let me show you. This is a bit of like wonderful trickery that I know of, that everyone knows of. And the effective address is made of a register. And then you have this. You have a assembler.com and a conversion. So now we're saying it has an object. We're giving it the conversion object, right? Then we store it. So private conversion converter. Here we go. This dot converter. This converter. Boom, done. So that's saved. So now when we get the register, instead of returning just the register, we go like this, which means now, so now the problem, oh my god, we keep going into problems, which is fine. I mean, that's what programming is. You keep going into problems. Now the problem is that I need to translate the D1, D0, D2, D3, D4 to the actual register numbers. So the way this works is I have to give it the data register number. There's 0 through 7, and I have to just return the binary representation down to 3 bits. That's what I need to do. So that means when I do git register, I actually have to give it. That's if I go to add. Oh my god, this is so confusing. So if, and this is what happens when you're stuck, guys, when you're programming. Talk through it. For me, at least, I can write it down. But I can talk and write. That helps a lot for me. By the way, guys, it is 35, so I just want to tell you guys something. Because you guys are awesome. All your watchers are watching. You can buy a shirt. I sell shirts online. They're fucking awesome. It's a fugly unicorn. That's great. So I have a website, www.thatprogrammerguy.com. You can get this image on a shirt. Just click on the image. Select a man or woman shirt, $40 per shirt. Buy one, be fulfilled in like 3 days, and be shipped right to you. These are great shirts. They're very motivational. They say, the best thing on them. Remember, you can do the thing. It's how I introduce everything with a really, really high fidelity fugly unicorn and rainbow on it. If you guys want a shirt, just go to www.thatprogrammerguy.com/merc and boom, done. You can select a shirt. You can select how many, add to cart, and buy it. Man, they're the best. They're also made with Gildan, the Gildan shirts, and Gildan is actually a pretty high quality t-shirt. I don't want to give you guys low quality shit like Fruit of the Loom. Fuck that. I'm giving you high quality Gildan quality shirts. So, if you want a shirt, they're great. Unfortunately, I don't have one with me right now. I probably should. Additionally, guys, if you're watching this on YouTube, if you like what you see, give me a thumbs up. If you hate what you see, give me a thumbs down. In any case, please let me know and subscribe. Subscribing tells me that you understand that learning is hard and it takes time, and that is okay. Or if you're watching this on Twitch, go ahead, please follow me. I love your follows. I want them all. I want them in a big hug. All right, now that that's over. The question is now, I need to take the effective address, and I need to give it. And I need to give it the D0 or the D1 or the D2 or the D3. I need to give it all that stuff. So effective addressing mode, I get the addressing mode, right? Get addressing mode, the instruction parts number 3 or number 2, binary.append. Effective addressing mode, effective, then get register if doesn't equal roll. Okay, so now we have to worry about the register part, which is just fucking fancy. So get register, I could do actually this. I could do a, get register. I can do this. If, no. That's not a good idea. Because I was going to do like, if register is null, do this. Otherwise, give back what you gave me. But then that would mean that get register would need to, that means get register that would have to include a string, which is the register. But if I already have the register included, I don't want to tell people get register always needs a string, especially when like I already gave you one. I don't need another one. Now I could make these ones of the effective address. I could say in there that if it's 111, 111, or 111, no, because that information isn't stored. So basically the problem I'm going through is in the add instruction, when we go to the add instruction, the effective address needs the register. The register is known on this side, but unknown on this side. So if I pass a D1, D0, the register is 000. If it's AN, or if it's like D1, it's 100. So I need to pass that information in when I know it. And I only know the information. I have the information here. If the source is basically this is how we get the effective addressing mode, get addressing mode, which basically takes the effective address, which is from the syntax, and gets basically new effective address, which contains the mode and register. But we don't know the register because this is just the syntax. No, we have it here. We have the effective address. We're just changing it. So we actually do have the effective address. So we can do it here. Oh, right. That's what I was doing. Oh, guys, I'm so smart. Why didn't you tell me? Okay, so figured it out. I figured it out, guys. The effective address is not going to have a converter in it. We're going to get rid of that. We are going to get rid of that. We are going to get rid of that. See, programming and something that's new does take a lot of time, as you can tell. Like, I've been doing this for quite a while. Talking to myself is a big thing. You gotta get to think. You know, keeping everything in your head is pretty impossible since humans can only keep between 7 and 9 things in their head at the same time. Additionally, you know, there's way more than 9 things that I'm dealing with right now. Offload it. Put it onto your notebook. It's okay. It's okay to use a notebook. It's okay to write stuff down. Writing stuff down doesn't mean you're like a bad programmer or anything. Write that shit down. Put notes. You're a human being. You know, as a software developer, our job is to manage complexity. As a software engineer, our job is to manage complexity. Part of that managing complexity is to put shit in a notebook. It's okay to use a notebook, guys. It's okay. It doesn't mean you're any less of a developer because of that. I just want to let you know that. All right, so what we have is here at the point, we actually have the effective address. And we're like, EA set register. We have a converter. And now we can set the register. Oh yeah, I did this wonderful fugly thing. I don't have a set register method, do I? Yes, I do. Oh, no, I don't. So public string set sweet register. This is data register to binary, which returns us a string. Yes, right? String. Cool. Wonderful. There we go. Oh, not a string. This is void. Yay! We're going, guys. Work in progress. All right, viewer who's watching me, you're fucking awesome. R-E-G-I-S-T-E-R. I would actually like to do this more. That'd be fun, but I do have other stuff I need to do. So if I can manage to do this like full time, that'd be great. However, if I actually do manage to stream full time, I'll probably take a break on the weekends. Because this is a lot of work. Alright, so basically now we have this. This is what we're doing. So now we have a effective address equals this. One of those, and then we go EA dot set register. Oh my god, set register converter dot data register to binary convert dot to int 32. This is n, so it's the same thing. Lower cased effective address. Very ugly. That's fine. Return EA. Awesome. So now we're going to do this. And this is going to get bigger and bigger and bigger and uglier and uglier and uglier. But that is okay. What's the lowercase effective address? This is everything. Okay. If negative 0, 1, 2, 3. No, damn it. I need to go back to where was I? God damn it. Negative AN, right? Lowercase of 2 lower. Yeah, I haven't stripped off the parentheses yet. So this is 0, 1, 2, 3. Not 33, 3. Return EA. I need a better word for EA. EA sucks. Alright. And then addressing mode is of XXX. We know that one. We know XXX. Alright, this one. Now this is when we have stripped off lowercase effective address. We have stripped that off, so now we don't have the parentheses anymore, so we have to watch out for that. Which is cool. We can totally do that. So we have 0 and 1. So that's 1. Return EA. There we go. XXXW. We should know the register of XXXW. Yes, we do. We know XXXL. AN. Parentheses AN, right? Haha, we don't know that. So... what? Didn't mean to do that there. Let's copy that. Boom. So parentheses are taken off, so it's again 0, 1. Let's return EA. Alright. So if affecting, now that everything's stripped off again, oh god, if effective address parts link this to, wait, oh no, this is 0, 0. So I need to do 0, 1. Oh, I need to figure out a better way to do this. If affecting address modes is a plus 0, 0, 1. There we go. All right, there we go. So now that we have that, wait, what? Yeah, okay, now we have that. Cool. Now we're at 2. So 0 is AN, so we have to do this. Effective addressing mode is this. D16 AN. Things are stripped. Convert. So we have 0, 1, 1. God, this would be so much better. What are you complaining about? Can I apply indexing to expression of type car? Oh, yeah. Effective address part 0, 0. What's lowercase effective address? Oh, I need to access the effective address parts. I need to do this now. That's what I'm looking for. Which means that's going to complain. There we go. Alright, guys. This should be things like don't use a lot of string shit. Strings are bad when you need to include logic. Alright, so PC. We know PC, which is great. AN, so we take this. We go like that. D8. AN, and then XN. Effective address parts 0, 1, 2, 0, 1, 1. That's what we're looking for. Copy. Oh, shit. That's what I need. All right. No. La 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 la. Ba 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 da ba ba da ba. Ba, 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 da, da. All right, so now we have, I think, what we need to have. We have if the register is here, so if we have a WL, immediate data, or we're using the PC, we know what register we need. If we don't have it, so DN, AN, asterisk, AN, blah, 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 all these, we now are we putting the register in there, which is great. So this should be done. So now we have addressing modes, effective address, get mode, and then if not null, then binary.append, get register. So, but now we're always setting it, so we don't have to worry about this anymore. We just have to go binary.append, append effective address dot get register. Wonderful. So now we finally did the 15 bits of the add mnemonic. That took forever. Yeah. Am I dropping any frames yet? Nope. Awesome. How's my CPU doing? Perfect. Sweet. Oh my god. Ah. Oh, that was pretty nice. So now we have all this wonderful stuff just for the 15 bits. Balls. So to show you guys what we have, to show you, and for me to as well go over it. So we have a string builder binary. This is what's going to hold the binary. We split the instruction parts up. Is this, we make a new converter. Instruction parts to 0. Okay. I'm already being like, what the fuck is this instruction part to 0? Let's change this a bit, because now I've totally forgot. So we have add, I don't know what's to instruction parts 0 is D. Add byte 0 1 2 with the source destination. Right? Source and destination. Okay, cool, wonderful. So let's get rid of some of these magic words, right? Let's get rid of, so it's 0 1 2 3. Let's have a constant here. Const private const int source is equal to 2, private constant co nst int destination is equal to 3, private const up size is equal to 2, no, 1. There we go. All right, so now this makes a bit more sense. Oh, I need to make this int, my bad. There we go. Cool. So now we have all that. So now we can go, if instructions part source destination op size. Get some of these magic numbers out of here. Get addressing mode, destination, source. There we go. Yay. All right. So great, wonderful. So now we have some magic numbers in here. Now we got some magic numbers in now. So now we can understand this a bit more. So really, this is saying, okay. So now it's like, if the source is the if the source is the data register, We append the 0 to 7 with the 3 bits, and we're saying, yes, the source is the data register. Otherwise, we use the destination because the destination is the data register. Then we make the operand factor, and we append the this thing, which we got from the manual. And then we go, okay, here's the addressing mode, the effective address. And then we get the effective address from the addressing mode based on what the source or destination is, depending on where the effective address is. And then we append the mode and append the register, and that's it. So that is that. Cool. So now, with the add instruction, all right, so basically now we should have like an append. So now I think what we need to do is we need to have a append effective address operation, single effective address operation word. Hold on. I fucked up here. Oh, I made a fuck up. Somewhere I did something. Single effective address operation word. Single effective address op. What is that? Single effective address operation word. What is this? So I think I understood, but then I don't. Single effective address operation word. Because the word is 16 bits. Specifies operation and modes. Go here. This is the mode. What's the operation? Unless it literally means this, the instruction format, which it might. I don't know. I think so. I don't know. I'm gonna assume that this is correct, although I might do some reading next week. So we have this, and then we have append instruction, append operand specifiers, append source EA, append end EA, and that's what we're looking for. So really, this add instruction should be looking more like this. So public string get instruction binary, convert instruction to binary, convert op mode. What do I call it? Convert op mode operand specifiers, convert special where's that retr there we go. Public string convert and then or source EA. I know I spelled immediate wrong. IMME DIATE immediate or source EA. Return no. Public string convert destination All right, everyone. I'm going to end the episode here. what we got done today was we basically researched where the other words go. For example, if you have a D16, where do we put that 16-bit integer for the effective address? We got it here. We finished up the addressing modes. So if you don't know the register, we made it so we can actually get the register and set it, which is what we're looking for. Not the best. It's also really fucking confusing. Conversions, we did that. So we then finished add to get the full 16 bits of the instruction. What you can expect next week is we're basically kind of just take this whole entire thing, put it into here, and we're gonna finish this up, and then finish this. Now we're kind of seeing a pattern going on, so we can start making interfaces or abstract classes if we want to. And we're gonna start to make this more a bit automatic, you could say. Because really, yeah, automatic. I don't know. So yeah, that's that. If you're on Twitch, please give me a follow. I would love your follow. I would say give me your subscriptions as well, but I'm not that cool yet. What else? Ow, why does that hurt? What the fuck did I do to my finger? Guys, if you're watching this on YouTube, give me a thumbs up if you like what you're seeing. Give me a thumbs down if you hate what you're seeing. In any case, please let me know in the comments below what you like, what you don't like, or if you just want to chat with me. I'm kind of lonely sometimes. Go ahead, chat with me. Subscribe as well. Subscription. When you subscribe, you are entering a community and family of people who know that learning is hard, and that's okay. They know that's okay. Learning is hard. It does take time, guys. Yeah, so this episode and yesterday's Haskell episode will be out on the 25th. Right now, my Haskell and 68K from last week will be dropping in about 30 minutes. Yeah, subscribe, ring that bell, give me a thumbs up, give me a thumbs down. If you're on Twitch, go ahead, follow me. I love you all. I stream every Saturday and Sunday at 11 in the morning. But yeah, guys, I love you all, and I will see you all next week.